Okay, we're gonna hope. All right, everybody, let's get started. I think maybe we are in good luck. I think it recorded everything until the computer died. So, uh, now look, we're on the factoring notes. Hey, we're ready. We're on the factoring refresher notes, and we're looking down at number 13. Okay, so the reason I wanted to just go over the ones in the homework that we did not do is because I wanted to make this connection right here. In this problem, can I factor that 2 out? No, see, in the problems that we just did, I could. I could factor whatever that coefficient was up front, and therefore it left me with another trinomial where my coefficient was still 1. But now it's not. It's not 1. It's a 2. So I have to factor this differently. Now there's a bunch of different methods that you guys can learn to factor this. There are 4 good ones. There's one that's called AC. There's one that's called the X method. There's one that you literally just call it the guess and check method, which is the way I've taught it in the past. But I'm going to try something different this year that I think is pretty simple. Okay. If you don't like it, then I'm going to also show you this guess and check method, which is also good. It just requires a little bit more understanding as far as just numbers go, which usually in honors class you guys are pretty good at. But anyways, let's go back. Let's look at this problem. Here's how we're going to do it. We're going to use this method. It's called the over-under. So when you have a coefficient that's not 1, the reason you can't just immediately do it as, I guess you could say, as quickly as what we've already done is because what multiplies to get that 2x squared? It's 2x and x. So because those are not both just x, it actually messes with our other values because we can't just look at the 2 numbers that multiply to get 18 and combine to get 15. We can't just do that. Think about it. What are 2 numbers that multiply to get 18, but they combine to get negative 15? Well, you would say, well, negative, negative. What multiplies to get 18 combines to get 15? Well, there's nothing, right? Think about it. What are your multiples of 18? You got 1 times 18, which combines to get 19. You got 2 times 9, which combines to get 11. You got 3 times 6, which combines to get 9. You don't have 2 numbers that will multiply to get 18 and combine to get that 15. And the reason is because these are not both just x. One of them's a 2x. So it changes the way you have to factor it because those are not both just x. Do you understand? Do you understand that it changes it? Not do you understand what the factors are yet, but do you understand how it changes it? Okay, so here's the method that I have seen that I think is actually pretty good because it's consistent and you don't have to think through all of your different possibilities of factoring. It's called over-under. Here's how you do it. You're going to take this A value and multiply it by the C value. Guys, what is 2 times 18? 36. So what we're going to do is we're going to ignore the A and we're going to make this an easy factor. We're just going to write x squared. So instead of 2x squared, we're going to write x squared. We're going to leave it minus 15x. But we're going to change that last term to A times C. What is 2 times 18 again? 36. Now we're going to factor this easy. Why can I factor this one easy? Because the first value is what? X squared. So we're going to factor it into 2 binomials. Ready? Real easy. What times what gives me x squared? X times x. What's the rule about multiplying to get a positive? They're either both positive or they're both negative. We look right here in the middle. What is it? They're both negative. So minus, minus. So now we get to actually look at it and say, hey, what 2 numbers multiply to get 36? are the same. They combine to get 15. 12 and 3. Right? Does everybody see that? To multiply to get 36, combine to get 15, my only possibilities are 12 and 3. Now listen, those are not my factors. This is where we bring A back in. This is the under part. Remember I said over, under? Here's the under. We put that A value under those two factors. Now, what do y'all notice in that first one? Is 12 divisible by 2? Yeah. So in that case, your factor is, what is 12 divided by 2? X minus 6. But does it reduce on the right side? So here's the trick. That factor, we're going to take this value that did reduce and we're going to move it, and that will become 2x minus 3. Those are the two factors that would multiply to get 2x squared minus 15x plus 18. Yes?
Why didn't you just take them to 2 and done, like, the 15 divided by 2 would be negative 7 on the bottom right? Like, why can't you just make it this?
Where the negative 7 point not come?
Like, at the very beginning, whenever we're trying to pull the 2 out, and, like, you can't pull it out of the 15, is what you said, but you could, it just be decimal.
I'm not sure I'll follow. Yeah, I don't.
Why can't you divide the negative 15? Like you can divide 2 by 18 by 2, but negative 15 divided by 2 would be 7.5.
But 7.5 can't be one of your factors.
So, like, you can't.
No, we're not going to have decimals as factors. Okay, now let me show you guys real quickly. Let me show you guys the guess and check method. Now, the first thing you guys showed me, or told me, was that to multiply to get 2x squared, your possibilities were 2x times x. Now, that's great, and that's an easy one because 2 times 1 is the only thing that gets me 2. The reason this sometimes gets even harder is, what if that first term is not a 2? What if it's a 6? Then all of a sudden I've got a possibility of 1 times 6 and 2 times 3. So I have to spend time kind of guessing, checking. So here's the deal. What we're doing is, with guess and check method, are y'all paying attention? I want y'all to see which method you like better. So don't zone out on me now. Okay, I need you with me. I want you to tell me the two numbers that could multiply to get 18. What is my list of two numbers that could multiply to get 18? What are they? 3 and 6, 2 and 9, 1 and 18. Is that it? Is that it? Okay, so here's the guess and check method. Sometimes you see it fast, sometimes you don't. But the guess and check method says, all right, I know it has to multiply to get positive, right? So what's the rule? They're either both negative or they're both positive. So I look in the middle, they're both negative, right? So I can go ahead and put them in there because I know it doesn't matter. They both get 2x minus or x minus, they both get it. So it doesn't matter which one I give it to. Then the guess and check method says, just start plugging those in and you check outside and inside terms until you find the two that give me 15. Now there's a couple of cool rules that you can live by, and that is you're not allowed, since there was no GCF at the beginning, there can't be a GCF along the way. So what would I not be allowed to put in with the 2x, for example? If I'm trying 3 and 6, what can I not put in there with the 2? I can't put the 6 in there. So I might try the 3 in there, and I might try the 6 over here. And then I check outside and inside. What is 2x times 6? And what is 3 times x? Well, 12x and 3x combine to get 15x. Well, there it is. The first ones we tried were our answers. And that's great. Sometimes it's the first one, sometimes it's not. That's the guess and check method, though. You literally just kind of plug them in until you find the ones that work. They're both plenty efficient. The reason I like the over-under thing is because everyone seems to understand how to factor when it's just x squared. Then you just add that little thing at the end where you put the 2 underneath it, and I think that helps. I think it makes the method easier. So we're going to try that again. Go to number 14. Now, first question, is there a greatest common factor here? Definitely not. So we're going to try to factor this trinomial into 2 binomials. And we're going to do it using the over-under method. So, what is 5 times negative 48? 5 times negative 48. Negative what? Negative 240. So here's what we got. Here's what we're going to factor. P squared plus 22p minus 240. Okay? Remember, this is an easy factor because it's p times p, right? Bless you. It's p times p. Now, to multiply to get a negative, what was the rule? What was the rule? A positive and a negative. So we're looking for the two numbers that multiply to get 240, but because those signs are opposite, they have a difference of what? Guys? 22. We're looking for the two numbers that multiply to get what? 240, have a difference of 22. Now, people think, well, that's a huge number. It's going to take a long time. It doesn't. Just start dividing. Go 240 divided by 2. You get 120. What's the gap between 120 and 2? Not 22. So go 240 divided by 3. 3 and 80. Still not there. 240 divided by 4. 4 and 60. Getting closer. Still not there. 240 divided by 5 is 48. That's a difference of 43. 240 divided by 6 is 40. That's a difference of 34. 240 divided by 6, or I'm sorry, 7, doesn't work. 240 divided by 8 is 30. What's the difference between 8 and 30? 22. It has to be 8 and 30. It doesn't take that long, even when your numbers are big. You're just grabbing your calculator and you're dividing. Yes, Ava?
How did you get 8?
No, I just started taking 240 and dividing it by numbers. So I started with 2 and then I went to 3. I was just trying to find multiples that will give me 240. So 8, I just came up with it. So 8 times 30 gives me 240. 8 and 30 have a gap of 22. Now look, what sign wins in the middle? Positive. So positive has to go with my bigger factor. So it's plus 30, it's minus 8. But are these my factors? No. We take these, and here's the under part. You put the 5 under them. Now look at that first one. Will 30 divide evenly by 5? What? So P plus 6 is one of my factors. Now look at your other one. Will 8 divide evenly by 5? Then what do we do with the 5? We move it up, so it's 5P minus 8. There's the factors of 5P squared plus 22P minus 48. What do you think? Not that bad? Okay, let's keep on going to the back side. Over under. Ready? What's 3 times negative 40, y'all? 3 times negative 40. Negative 120, right? So we're going to change this to h squared minus 19h minus 120. Now we can do an easy factor. What times what gives me h squared? H times h. What times what gives me a negative? A plus and a minus. So we're looking for the two numbers that do what? Multiply to get? No, multiply to get negative 120, but have a difference of 19. Right? Multiply to get 120, have a difference of 19. So here's where I go to my calculator and I just start dividing. What's 120 divided by 2? 60. 2 and 60 has a difference of 58. That's not it. 120 divided by 3, that's 3 and 40, not it. 120 divided by 4, 4 and 30, that's 26, getting close. 120 divided by 5, 5 and 24, there it is. 5 and 24 have a difference of what? 19. It took me typing in my calculator for 3 seconds. When you divide 120 by 5, it's 24. So your two factors, 5 and 24, will multiply to get 120, but they have a difference of 19. So it has to be those two numbers, 5 and 24. So here's my last thing. What sign won the middle?
5.
What sign won the middle?
Plus.
Nope, what sign won the middle?
Oh.
What sign won the middle, y'all?
Negative.
Negative won the middle. It has to go with your bigger factor. Which is bigger, 5 or 24? So it's minus 24, it's plus 5. Now, we bring the A back in. Divide by 3, divide by 3. Will 5 over 3 reduce? So this goes where? In front of the H. So that factor is 3H plus 5. Will 24 divide evenly by 3? So that becomes H minus 8. So my two factors are 3H plus 5 times H minus 8. Questions about that one? Y'all feel okay? Alright, let's look at one where it's a little different. Okay, you take, for example, number 17. The reason the guess and check method would be tricky on this one is because what are some things that multiply to get 6? You have 1 times 6 and you have 2 times 3. So now you have 2 different options in that first spot. But the over-under rule eliminates that. Watch. What is 6 times negative 21? Negative 126. So here it is, guys. We're going to use y squared minus 5y minus 126. And we're going to factor that easy style. Ready? What times what gives me y squared? What will multiply to get a negative? A plus and a minus. So we're looking for the two factors that will multiply to get 126, but have a difference of 5. So I literally just go like this, guys. 126 divided by 2. No, that's 2 and 63. Not it. 126 divided by 3. 3 and 42. Not it. 126 divided by 4. Nope. 126 divided by 5. Definitely nope. 126 divided by 6. 6 and 21. Also not a gap of 5. 126 divided by 7. 7 and 18. That's a gap of 11. We're getting close. 126 divided by 8. 126 divided by 9. There it is. 9 and 14. It doesn't take long to find factors, is the point I'm trying to show you guys. This was that note sheet I gave you on Friday. Okay. 126 divided by 9 gives me 14. 14 times 9 gives me 126, and the difference between 14 and 9 is 5. Okay, so what sign wins in the middle? Negative. So negative has to go with my bigger factor. Which one's bigger? 14. So it's minus 14, it's plus 9. Now watch this. This is the first time this has happened. Now we're going to divide those by your A value, which was what? Will either of those just cancel out? No. So here's what we do. We reduce them. What will 9 over 6 reduce to? What will 9 over 6 reduce to? No, not decimal. No decimals. Fractions. What will 9 over 6 reduce to? 3 halves. 3 over 2. What will 14 over 6 reduce to? 7 over 2. Oh, I'm sorry. 7 over 3. Right? So my factors are, where's that 2 go? 2y plus 3. And then what about that 3? 3y minus 7. And its factor. Okay? So if it completely is gone, that's great. If not, you simplify it, and those are your factors. And that's how you do the over-under method of factoring. Now listen, is this necessary when you have a trinomial that has an a value of 1? No, because if you multiply a times c, it's the same value. This is only necessary when your a value is not 1. Y'all understand? Let's do another one. Look at number 19. We're actually going to do 2 more. What is 9 times 4? So here we're going to factor x squared minus 12x plus 36. Y'all with me? Remember, we just let the a disappear so we can factor this easy style. Why is this easy? Because what times what gives me x squared? X times x. What multiplies to get a positive? Either 2. So in this case, you look at that middle sign, it has to be 2 negatives. Now, finally, what 2 numbers multiply to get 36 combine to get 12? 6 and 6, right? These are a little easier because the numbers are smaller. Now, don't forget, you always take those, divide them now by a, because our a value was not a 1. Now, what does 6 over 9 reduce to? 2 over 3. And they're both the same. So my factors are what? 3x minus 2 and 3x minus 2. Okay? Questions about that? What time do we got here? So we're really close? Okay. Last thing. Sometimes, guys, please don't forget, you could waste a lot of time trying to factor a problem like number 20 because we always, and I haven't said it a single time through any of these, we always forget to check what? Greatest common factor. Now, luckily, none of the ones we've done have had one. But if I go into factoring this, I'm just wasting a ton of time because notice, can you pull something out of 8, 56, and 96? What's the smallest number of those 3? 8. Will 8 go into 56? Will 8 go into 96? Check it real quick. 96 divided by 8. Yeah. See, you can pull an 8 out. Don't forget to check GCF. Okay? I haven't been saying it every time, and I should have, but our focus was the factoring. But if I pulled an 8 out of this problem, look, this becomes y squared plus 6x, or sorry, y, plus 6y plus, what is that? Sorry, 7. Bad division. Plus, is it 12? So now it's just an easy factor anyways. You take the 8 out and you factor this into 2 binomials. It's y times y, so we don't have to do any hard work anyways. What multiplies to get positive? Either plus plus, minus minus. I looked in the middle, definitely plus plus. What multiplies to get 12? Minus get 7. And there's my factors. We don't have to do anything with that because my a value was already 1. It wasn't something else. We factored it out of every term. So, there you go. We didn't have time to get the difference of squares today. I really wanted to, but probably do it anyways. So, I'm going to stay with me for a second. I'm going to tell you which problems of these I want you to do. Hope this method is going to... Oh, sorry. Oh, just not fast. Might want to mark the ones that we go for homework. Beg your pardon? Might want to mark the ones that we go for homework. Oh, mark the one. Okay, here we are. Here's the homework I want you to do. On this page I just handed out, I want you to do number, definitely 4. That was easy. I want you to do 5, 7, 9, 10, 11, 13, and 14. So 4, 5, 7, 9, 10, 11, 13, 14. Okay, that's your homework for tonight.
You care if I go now?
Go.
Awesome,
Yeah.
thank you.
What kind of